These two graphs are inverses of each other, and I'm going to explain why that is. Just not, that's weird. Okay. So that graph and that graph are inverses. Shh. So example one, did most of you get the sketch yesterday? It's just a sketch. It doesn't have to be exactly right, okay? The name of this, well, it should be the name of this lesson is we're actually just going to be sketching the inverse. It's very hard to be exact when you're given the graph. So we're going to find the inverse of this function. We're going to sketch it. Where these points are, it matters. So notice that they do cross at certain points. For example, this point right here is -3, 5. This point is -2, 3. So I'll take that back. You do need to be at least understand that those points exist, because you have to have, what I like to do is teach you at least 4 points to use to sketch the inverse. So that leads us to step one. You're going to pick 4 or more. Pick 4 more points on the graph of the original. Okay? Now, pick unique pivotal points. Now, for a line, it's not so much important, okay? But what do I mean by pivotal points? Well, if you had, for example, a parabola like this, you wouldn't want to just pick points on the right. See what I mean? If you just pick those 4 points, that doesn't really complete the shape of the parabola. You would want to pick points that form the U of the parabola. So pivotal points basically means important points. Okay? So make sure that by pivotal again, make sure those points complete the shape of the graph. For example, with this parabola, or let's say you had something like a cubic function, you would want to pick a point here, maybe a point in the middle, and then 2 points up here to make sure that the inverse graph takes on the same shape. If it's a line, like I said, it's not too much of a, yeah, it's like the one we're doing right now. That's a line. Yeah. Well, you do want to at least make sure you pick that point because it's an endpoint, so I would consider that a pivotal point. The other 3 don't matter so much, okay? Here are the points that I picked. So 0, 2 is going to be a point, and then -2, 4, -4, 6, and -6, 8. So once you pick 4 points that complete the shape of the graph, step 2, we're going to write out the point values, which is easy, right? I mean, you literally just determine what each point is. And here are the 4 points I just mentioned. So again, write out the point values, and here are the 4 points. So 0, 2, -2, 4, -4, 6, and -6, 8. Those are the 4 points. Make sure you write them out. Flipping the points, we're going to flip the points that we got to get our new inverse points. First point we're going to flip is 0, 2, becomes 2, 0. And we're going to flip -2, 4, becomes 4, -2. We're going to flip -4, 6, becomes 6, -4. And we're going to flip -6, 8, becomes 8, -6. You need to turn around. Right. So your original points get transformed by flipping them, and they become your inverse points. All these points right here. Okay, next we're going to plot those points. So we're going to plot all the points, these points right here that we just came up with, we're going to put them on the graph. Okay, so plot, you could plot your inverse points for step 4. Excuse me. So they're going to look like that. So we got 2, 0, 4, -2, 6, -4, and 8, -6. Anybody want to make an observation about how that relates to, remember the original graph somewhere up here. So what's the relationship? Same slope, okay. One's positive and one's going the inverse for what? They'll run together, okay. Step 5, and these points will be on the next graph, so copy it there. I'm going to connect them with a similar curve. Now a line is, I guess a line is actually technically a curve, but it's not really, right? It's in other words, you want to connect them with the same shape. Now for this first example, it's simple. It's already a line, but the point I'm making is if your original graph looks like this, right? Your inverse graph should look like that. Your inverse graph is going to look like this. It's going to be the same shape, but it's going to be pointed differently. So I do that because we do this step because I've seen students try to draw an inverse graph. It doesn't look like the original. In other words, you need to kind of understand how to connect the dots. The shape should be the same. The position is going to be different. You guys already kind of got the point here. For this one, it's going to be the same shape. It's going to be pointed in the opposite direction. Here's example 2. Yeah, well, not any 4. We want to choose 4 that make sure we complete the graph. So again, you wouldn't want to just pick points up here, right? And you wouldn't want to pick points down here. Certainly one point you definitely want to pick is this one. That's definitely a pivotal point. It's where kind of the curve changes, right? There's a word for that for calculus. It's called an inflection point. But we want to pick 4 points that complete the graph. Okay? So these are the 4 points I picked. You guys can go ahead and you don't have to label the entire axis on your notes. Whoops. You can you don't have to label all those numbers, but at least label these points here. So we got 1, 2, we got 3, 5, we got -1, -1, and -2, -7. Next, we're going to write out those values. So just like I just went over, these would be our 4 points. What would be the next step after that? See, yep, we're going to flip them. These points are going to be on the next page. So we're going to flip the points, and that's what they look like when they're flipped. 3, 5 becomes 5, 3, -2, -7 becomes -7, 2, -2, so on and so forth. All right, final step, we're going to take these points that we just came up with, and we're going to graph them or plot them. And here's where the shape is important, okay? Once we plot these points, we got to make sure we connect them with something that makes sense. In other words, it needs to look like the original graph. Of course, it's going to look different in a way, but the shape itself should be similar. So here's what happens when you plot those 4 points we just came up with. They look like that. Here's an example of what you wouldn't do, okay? You wouldn't make 2 lines like this. Does everybody understand that? That looks nothing like the original, okay? When I connect it, it needs to be a similar curve as the original. A curve. See how this curve goes like this? One way that helps you understand which way to go. Sometimes what I do is I draw a dotted line, a diagonal dotted line that goes through the center like that. So it's going to be pointing, how would you say, from southwest to northeast, okay? The curve is going to be a mirror reflection of this. This isn't going to be the best, but it's going to be opposite of that line like that, okay? So it's like flipping it over a mirror. So that'll give you an idea of what the curve should look like. So the new curve is going to be like an S. And it's going to look like that when we connect the dots. So notice this curve is actually flipped over that dotted line we just drew. And if you need help, I know it's going to take a little practice, I understand that. But certainly you can always ask me, hey, Mr. Underwood, which would be the best way to connect these dots? I'd be happy to help you out. Let's do one more example. Don't go too far. Okay. Does anybody know what type of graph this is for example 3? So it's a square root function. When you have a curved ray like this, where it kind of looks like a ray but it curves, that's a square root usually. Okay, so can somebody tell me one pivotal point for this graph? In other words, a point you absolutely need. 2, 1, yes. Okay, in other words, every endpoint on a graph should be used. And then of course, the other 4 points, you have to go this way, right? There's no points to the left. So here's the 4 points. Smaller. Here's the 4 points we're going to pick. First one's 2, 1. Next one is 3, 2. And we got 6, 3. The next one kind of goes off the graph, but looks like 11, 4. Okay. So here's the point values right here. Any questions on that? So you guys see the steps are the same for every graph. Just make sure you follow these 4 or 5 simple steps. Flip the points to get the new ones. So it'll look like this. 2, 1 becomes 1, 2. 3, 2 becomes 2, 3. 6, 3 becomes 3, 6. 11, 4 becomes 4, 11. Next, we're going to plot the points, or inverse points. It's going to look like this. This one's easier to connect, okay? The original one kind of looked like this, and again, you can kind of see it's going to be flipped over that, right? This one had an endpoint down here, so this one's going to have an endpoint. When we connect them, it's just going to go like that. Final answer should look like that. Okay, any questions about any of these?